Shri Atul Khare, Executive Director, Coordination and Project Works, DMRC. An IRSC officer, Shri Khare has led major metro and freight projects across India. He currently oversees metro construction in Delhi and Mumbai and specializes in AI-enabled asset management and innovative infrastructure delivery, enhancing efficiency across the rail ecosystem. His notable contributions executed a landmark project involving the design and construction of a 353-kilometer double line for freight rail traffic, which included a state-of-the-art central operation control and command center equipped with SCADA technology and a large video wall. Let's all together welcome Shri Atul Khare on stage.
Good morning, everyone. I think it's in the industry session, the presentation is for the infrastructure or the modernization. It's a little misplaced, but it's nevertheless. I will talk about the Indian Railways, the modern systems being used and which are in pipeline for project construction, infrastructure management, especially in track and civil engineering sector. Say for maintenance of track, we have introduced Indian Railways, the integrated track recording car. Most of the things which are being taught about in this session or in the previous session, most of the features are incorporated in this integrated track inspection car. We have all measurements online, continuous measurement, simultaneously online processing, reporting the exceptions and analysis also within the system, and it is on time, it is IoT based, it is reported on a system, it's monitored at every level in this railway server, so it is a state-of-art integrated track monitoring system which is existing, which has been provided in Indian Railways, and it is in pipeline. We are also introducing a few more. The next is the rail inspection vehicle for rail profile measurement and for other inspection uses. We have also introduced, I am not putting up the figures, what is in the pipeline and what are being procured, because it will be a little sensitive data. So the rail inspection rail profile measurement vehicle is also in the pipeline. It is used for practically for rail, for measurement of rail profile, which is being used for rail grinding, which is being used for analysis, which is being used to increase the rail life, so that by doing effective grinding, by reprofiling the rail, we use this vehicle. The next is, this is the recent introduction in last 1 or 2 years. Normally the phased array is being used as a standard ultrasonic means for other applications. It was not being used in the railways, but from last say 2 years or so, we have introduced phased array testing, phased array ultrasonic testing of rails. We have introduced this for welding, and slowly it will be proliferated for rail inspection also. So it's a complete solution as far as the rail inspection, the ultrasonic inspection. It's a foolproof. It's the safety level increases manifold. Then for bridges, the continuous water level monitoring at all important bridges is being adopted. It's a 3D river mapping also we are doing. It's a ultrasonic based, it's a real-time monitoring, again linked to the servers, continuously monitoring at railway board level or at headquarters level. So this we are doing. Then again, scour monitoring and the inspection of bridges by drones. This is also being used. Drones we are using, and it has got AI also inbuilt. So whatever the industry partners are available, they are also welcome, that if they have certain ideas, certain suggestions or certain improvement which we can do in Indian Railways, and metro railways, you are welcome. For track maintenance, so far as the maintenance were being used by the conventional method, now we have acquired rail-borne maintenance vehicle. It will have the maintenance equipment, it will have the maintenance spares, and will carry out the manpower also. We will go to the spot and attend to the specific location and come back so that our productivity increases. This is also a large number railways is being procuring these vehicles. Then again a utility vehicle, this is almost similar. The earlier one was for inspection, this is for the attention. The tamping machine, state-of-art tamping machine by different vendors have been procured. Further are in pipeline, large number of tamping machines, high output tamping machines are being manufactured in India, of course with the technological partnership with the different industries, and which is being procured for increasing the speed and the productivity on Indian railways. The ballast, most of you might be knowing the passage of time, the ballast get contaminated, and for increasing the speed and the resiliency, the ballast needs to be screened. So far as I would say about 5 years back or maybe 10 years back, this was being done manually. So the high output ballast cleaning machines, which are able to not only clean, but to restore the traffic to the original speeds. So high output ballast cleaning machines have also been introduced, which are also, because what is happening in railways is planning, in the first session it was said that about 1,30,000 crores of money is being pumped in infrastructure. So last year it was 2,40,000. So you see, and practically half of this is going for infrastructure improvement. We are doing a lot of money. Every year we have, and in Indian Railways have set the target of around 7,500 kilometers of track being added every year. So for this much track and for this much project construction and for maintenance, definitely railway is not going to increase their manpower. So such machineries are helpful. So these are one of this machine, ballast cleaning machine. Then for construction of this, which I was talking about, in the dedicated freight corridor, the entire dedicated freight corridor have been laid with the track relaying train. And especially the project which was the first project of DFCC, which was from Kanpur to Khurja. We were practically laying 1 kilometer a day by a machine. And we were having 3 machines. So the 3 kilometer a day track laying was possible with this machine, which I am showing in the second photograph. This has now been adopted on Indian Railways also. There are 2-3 vendors which are manufacturing in India and now supplying. So one is earlier the version, the first photograph is used for track replacement, and the second one is for the new track construction. So these are the 2 machines which we are using. Rail grinding machine, as I mentioned, that for increasing the rail life, the rail needs to be profiled to different profiles to reduce the development of defects in the rail and to increase the service life. So the rail grinding needs to be done. And now with the existing rail, which we call it the gross million ton, the GMT, which was around 800, the rail life was earlier 800, now is being used, increased to 1,000, or we have seen that up to 1,200 GMT, the existing rail is surviving because of rail grinding and because without any defects. So the rail grinding is also being used in big way. There are many machines which are coming on Indian Railways. This is the ground penetration radar, again mounted in the first vehicle, which I have shown the integrated track monitoring. So we can also measure the cushion, the penetration of ballast below the formation. We can analyze what is the problem in formation, etc. This is the later development, which has an offshoot of dedicated freight corridor, which was being used earlier in different railways. The crossings, typically the cut sound which we are getting with the passage of rail. So this cut will not be listened by doing the weldable crossing. So the crossing end are welded now. The rail expansion joint is a typical solution. The expansion joint has been replaced by this expansion joint. As some of you may be aware, if you are conversant with the civil engineering, that on the turnout, we have a provision of cant 1 in 20 in the normal section, but so far the turnouts were not having any cant. Those were laid in the plane, horizontal plane. So just to improve because now the railway is aiming for the semi-high speed on the normal track, which is in the order of 180 to 200 kilometer per hour. So for this, the turnout should also be canted with the same cant as of the normal track. So the canted turnout is being introduced, which was adopted in DFCCIL first time, now being implemented on Indian Railways also. Again, for inspection of such number of such large track length, the precision, the speed is also required. So now the conventional trolley inspection is being replaced by a motorized vehicle which will be rail cum road. It can be put on the level crossing, can be removed on the level crossing, and so that the inspection is carried out like a conventional road vehicle which is being run on the railways. Is equipped with all the inspection equipments, so we can carry out a real technical objective inspection by this rail cum road inspection vehicle. This is another type. The point machine, which conventionally is being housed by the side of the rail, by the side of the track. Now we are putting it within a hollow sleeper, which will have the point machine built in. So this also is being tried on Indian Railways. It's around 50 numbers have been ordered. This will be introduced in near future. Then the use ultrasound sonic testing of rail and welds is so far being used by manual walking trolleys. So these trolleys are being replaced by a motorized vehicle which will be used, and about say 10 numbers or say about more than that are being procured on Indian Railways. That's all. These are the all modern things which are being used. Thank you, sir. Of track?
I have one question on efficiency and accuracy of track maintenance. You have listed a lot of machinery. Now in future, high speed and semi-high speed will be coming, the speed will be 300 kilometer, 350 kilometer per hour. Whatever the machineries you have informed, I think it is for the routine maintenance of work. Is there any machinery or technology which can be used for coverage technology, where safety integration level number 4 will be there, as well as for high-speed trains, where speed will be nearly 350 kilometers per hour? My question is on technology and machinery for efficiency and accuracy of track maintenance.
Sir, with the introduction of machineries for track maintenance, the accuracy of, say, the products or the parameters will going to improve. And for introduction of semi-high speed and high speed, the track tolerances which were otherwise defined for a conventional speed, say about 120 kmph or so. So number one, we have changed the track tolerances so that for higher speed, the accuracy of track parameters is to be there. So the tolerances have been reduced, and by introduction of machines, we will be in position to maintain those tolerances. So if it is a tamping machine, the tolerances will be better. And you are telling something about the Kavach also. Actually, all these machines will require to be equipped with the Kavach technology. So while working in a occupied, section, when the section will be occupied, so the machine should have the Kavach features, so that the fail-safe mechanism against any collision and accident is avoided. So number one is the parameters and the accuracy will improve, and number two is the safety incorporation will also be required. This is being done, not as of now, because after introduction of Kavach on all the track, then the machine will be later. Thank you. Yeah, okay, that's all. Thank you.